Hi friend, here a question from Net Math June 2000. Let code A, question number 77. Here the question basically from linear algebra. The topic of this question is basically the inner product space. Let Rn cross Rn to R be a standard inner product space. For a non-zero W vector W belongs to R to the power n, define T suffix W Rn to Rn by TWV equal to V minus 2VW by WW inner product WW for all V belongs to Rn. Then which of the following are correct? Option 1, determinant of TW. TW means the matrix representation of this determinant of this matrix TW matrix is 1, option 1. And option 2, TWV1 comma TWV2, the inner product of these two term is equal to V1 V2, right? This implies that TW is orthogonal. I discuss here. And option 3, TW is TW inverse. The matrix is equal to is inverse. And option 4 is T2W is equal to 2 into TW, right? T suffix 2W is equal to 2 into TW. So which of the following are correct here? So now I give the general solution of this problem. This is a very important question from linear algebra, basically from the inner product space. So what we will determine first? The matrix representation of TW, right? The matrix of TW here we determine and check all the option. So first, suppose E1 is equal to 1 0 En is equal to nth position is 1 and all are 0, right? This is nth position. So these are the bases of R to the power n. So what is TWE1? This is equal to E1 minus 2 inner product E1W by inner product WW into W. So given that W is, which is what is W? W is any member of R to the power n. Suppose W equal to x1 dot 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 xn, right? So this gives, this is 1 0 minus 2 x1 into here x1 dot 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 xn, right, by this is norm W whole square, because we know that inner product of any two vectors is equal to norm of vector square. So this gives 1 minus 2 x1 square by norm W whole square comma 2 x1 x2 by norm W square minus 2 x2 x1 x3 and norm W square, and it is right. The last term is minus 2 x1 xn and norm W square. Now next TE2, this is minus 2 x2 x1 by norm W square 1 minus 2 x2 square by norm W square minus 2 x2 x3 by norm W square, and the last term minus 2 x2 xn by norm W square, right? Similarly TEN, what we will get? We get minus 2 x n, right, x1 by norm w square, and the last term is 1 minus 2xn square norm w square. So this is, so what is TW? The matrix representation with respect to the basis. This is orthogonal, and this is orthonormal basis, because here E1, E2 dot 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 En are orthogonal and orthonormal both. Now TW, what is TW matrix? We write this column or this row. So 1 minus 2x1 square by norm w square minus 2x2 x1 by norm w square, right, and here dot dot, and next, and this, right. So minus 2x1 x2 by norm w square 1 minus 2x2 x2 square by norm w square, and so on, and the last is this. So minus 2x1 x2 by norm w square, right, and next, this is not comma, this is a matrix. So minus 2xn x2 by norm w square, and the last term 1 minus 2xn square by norm w square, and this is this term. So we get this matrix. Here is a term and here also. So this is the matrix representation of TW, right? So in this matrix representation, this is very difficult to check the option, because here x1 x2 is arbitrary. So we take a particular value of this and we discard the option. So first we choose, suppose w equal to this, we let, so we choose x1 equal to 0 and other, sorry, first we take x1 equal to 1 and others all are 0. So what TW becomes minus 1 and all are 0, right, and all other are all 0. So what is determinant of TW? Is obviously 0, right? So option 1 is not correct. It is clear, because here determinant is 0. If anybody take this type of W in R to the power n, so here determinant is 0. So determinant TW is not 1. So option 1 is not correct. T of 2W V equal to V minus 2 V2W, right, by 2W comma 2W into 2W. So this is equal to V minus this 2 becomes here, so 4 VW, and this 2 4 WW, and this is 2W. So this is cancelled out. So V minus 2 VW by WW into W. So this is equal to actually TW. So here the option 4 is given that T of 2W equal to 2 of TW. So this is wrong option, right? Now the next we check the option 3. What is option 3? Option 3 is TW equal to TW inverse. So you check, we get TW, this we take for simplicity 2 cross 2 matrix, right? Sorry, this is a problem here. Their determinant of TW does not equal to 0. So TW inverse does not exist. So in this sense, this option is incorrect. but if TW inverse exists, then this is correct. This is question here. We take E1 equal to, we take here W equal to 1. What we will take? We take here W equal to 1 and all component are 0. Then in this case TW inverse does not exist, right? So if we take W equal to, suppose W equal to 1 1, right? Then what is TW becomes 0 minus 1 and minus 1 0, right? Now what is TW inverse? Is also 0 plus 1 and plus 1 0 by minus 1. So this actually TW. So if TW inverse exists, then TW equal to TW inverse. If does not exist, then we nothing to say. But if exists, then it equal to its inverse. So in this sense, option 3 is correct. Now we check option 4. What is option 4? Option 4 is given that T of V1 and T of V2 is equal to V1 V2, right? For all V1 V2 belongs to R to the power n. Check this option. Suppose we take V1 equal to E1. What is E1? E1 is first component 1 and all others are 0. Then what is TWE1? This is minus 1, all are 0, 0 minus 1, all are 0. Put the relation TWV in above, put here. So this is actually inner product space with dot product, which is 0, right? TWE1 this. This is TWE1 is this, right? And TWE2 is, what is E2? E2 is 0 minus 1 and all other component are 0. So 0 minus 1 and all other component 0. So what is TWE1? The inner product TWE2. What is this? This is actually 0, minus 1 into 0 0, 0 into minus 1 0 and all other 0. So this is standard inner product base, so this is 0. And what is V1 V2? This is actually E1 E2 we take here, so this is also 0. So option 4 is correct. We take example 2. So option 3 and 4 correct or incorrect, but this is not 4, this is 2 actually. But in general it also can be so. Then option 2 and 3 is here correct, right? So first option here is determine TW equals to 1. So this is incorrect and this is also incorrect. But in these two there is a confusion, because if TW inverse exists then equal, so this is maybe correct or incorrect in this sense, and this is obviously correct. So if exists then correct, and if not exist then this is invalid option. So thank you for watching.